In today's video, we will see how to construct extension field. Construct extension field. Example is Galois field 2 raised to 3. We have to obtain the elements of Galois field 8. From the base field is Galois field 2. So this is very common question which is asked in the university exam for theory exam. So let us see how to obtain the elements of extension field. So for that you need primitive polynomial. Now, what is primitive polynomial? The video is available on this channel regarding primitive polynomial. Here the primitive polynomial is one which is irreducible over Galois field 2. That means it does not have roots over Galois field 2, and it divides only x raised to 2 raised to 3 minus 1 plus 1. That means it divides only x raised to 7 plus 1. It does not divide anything less than 2 raised to 3 minus 1. That means x raised to 2 raised to 3 minus 1 plus 1. That means it does not divide x raised to 6 plus 1, x raised to 5 plus 1, x raised to 4 plus 1, like that. It divides only x raised to 7 plus 1. That means primitive polynomial is a root of x raised to 7 plus 1. Okay, so this is important about primitive polynomial for this case. Now, if you for obtaining the field elements of Galois field 8, you have to obtain the or factorize x raised to 7 plus 1. The factors are x plus 1, then x cube plus x plus 1, and x cube plus x square plus 1. Now, how you obtain these factors, that we will cover in the next video, because otherwise the video length will increase. So if you factor this, you will get these factors. So why we have obtained the factors? If you multiply these two, then that will give you x raised to 6. That will be other factor, but we have modified the factor such that we are getting the power 3, because we have to construct 2 raised to 3. That means this 3 and the power of the primitive polynomial should be same. Okay, so this 3 and the power of primitive polynomial should be same. That's why we have collected the terms of the factors of x raised to 7 plus 1 such that we get we get the factors with the power 3. Okay, that means what we understood that primitive if we have you have to construct here Galois field 2 raised to 3. That means primitive polynomial should have the factor 3. So should have the degree 3. Then it should divide x raised to 2 raised to 3 minus 1 plus 1. That means it should divide x raised to 7 plus 1. This is g of 8. It should divide x raised to 7 plus 1. If g of 16, it should divide x raised to 15 plus 1. Not less than any power like x raised to 6, 14, 13, like that. So this is so. If you recollect the things like that, it will be easy. That means primitive polynomial should have degree 3 and it should be factor of x raised to 7 plus 1. These two things are important. So let us take. So among these, for today we are going to take the factor you can take the factor anything, primitive polynomial as x cube plus x plus 1, or you can take a primitive polynomial as x cube plus x square plus 1. Among these two you can take any one, because you want the degree of the primitive polynomial to be 3. You cannot take x plus 1. Okay, you can take primitive, but you will not get the you will not get the solution as per required. Okay, so or that will not be useful extension field. So Galois field 2 raised to 3. We are taking primitive polynomial equal to x cube plus x plus 1. Okay, so once again I repeat the things I have told. We have to construct Galois field 2 raised to 3. For that we require what? Primitive polynomial. Primitive polynomial should have the degree 3, and it should be the factor of x raised to 7 plus 1. So we selected this one. So for that you need to factorize x raised to 7 plus 1. So we have selected this one. Now primitive element is root of primitive polynomial. Now what is primitive element? That video is also there available on this channel. You can check that video also. So primitive element is the root of this primitive polynomial. So let primitive element is equal to alpha. You can take A, B, C, D, anything. We have taken alpha. Now as primitive polynomial is root of x cube plus x plus 1, so alpha cube plus alpha plus 1 is equal to 0, because alpha is the root of this equation. So if you put the alpha in that equation, you will get answer 0. So alpha cube equal to minus alpha minus 1. But in XOR or Galois field 2, minus is equal to plus. So alpha cube is equal to alpha plus 1. Why minus equal to plus? Because 1 plus 1 equal to 0. XOR operation is there. So alpha cube is equal to alpha plus 1. This we have got. Okay. So once again, we have to construct extension field, Galois field 2 raised to 3. We need to factorize x raised to 7 plus 1. This is Galois field 8. So we need to factorize x raised to 7 plus 1. We have factorized in such a way that we get the polynomial of degree 3. And we have selected that one of them as primitive polynomial. Then we know that the primitive element is the root of primitive polynomial. So we have put the primitive element in that equation of primitive polynomial and equated it to 0. We got some equation alpha cube is equal to alpha plus 1. That means whatever the extension field we are obtaining is over mod primitive polynomial. So what is that we will see afterwards. Okay, so after that, so we are with basics now. We are with the pre-required things now in our hand. So we want Galois field 8. It has elements 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. 0 to 7 elements are there, because 8 elements are there. Now what is primitive element? Primitive element is one whose powers represent all the elements except 0 of that field. So 0, instead of writing this, I can write 0, alpha raised to 0, alpha raised to 1, alpha raised to 2, alpha raised to 3, alpha raised to 4, alpha raised to 5, alpha raised to 6. Now Instead of writing like this 0 to 7, we want generalize extension field. So what we did that we have represented it in terms of powers of primitive element. 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements are there. Okay. And now these are the elements of extension field. But we have to obtain these elements over what? Over 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 mod primitive polynomial. So 0 is equal to 0, then alpha raised to 0 is equal to 1, then alpha square, but alpha cube, because we are obtaining using the primitive polynomial x cube plus x plus 1, where alpha cube is equal to alpha plus 1. For that, for obtaining we are performing mod operation with primitive polynomial. So alpha cube is equal to alpha plus 1. Now alpha raised to 4 is equal to alpha into alpha cube. So that is equal to alpha. What is alpha cube? Alpha plus 1. So that is equal to alpha square plus alpha. Okay. What is alpha raised to 5? Is alpha into alpha raised to 4. That is equal to alpha square plus alpha. So that is equal to alpha cube plus alpha square. What is alpha cube? Alpha plus 1. That is plus alpha square. Now what is alpha raised to 6? Is alpha into alpha raised to 5. That is equal to alpha into alpha plus 1 plus alpha square. That is equal to alpha square plus alpha plus alpha square plus alpha cube. Alpha square plus alpha cube. That is equal to alpha square plus alpha cube is alpha plus 1. So alpha plus alpha, that means XOR. This plus is nothing but XOR operation. We are doing it over Gauss field 2. Okay. So we are not representing it with the or XOR, not XOR, but over the elements are coefficients are over Gauss field 2, and over Gauss field 2, 1 plus 1 is equal to 0. So answer is 1 plus alpha square. So you got the elements of the extension field Gauss field 8. 0 is equal to 0, alpha raised to 0 is equal to 1, alpha raised to 1 is equal to alpha square is alpha square, alpha cube is alpha plus 1, alpha raised to 4 is equal to alpha square plus alpha raised to 5 is equal to alpha square plus alpha plus 1, alpha raised to 6 is equal to alpha square plus 1. This is one method. Just for better for more understanding, I will just explain how this is nothing but the mod operation over Gauss field over that primitive polynomial. So alpha raised to 6 you got it as, suppose alpha raised to 6 you got it as 1 plus alpha square. There is another method to obtain it. We are obtaining it over Gauss field over the primitive polynomial alpha cube plus alpha plus 1. So you have to obtain mod, or you have to divide alpha raised to 6 by alpha cube plus alpha plus 1 and obtain its remainder. Okay, so alpha raised to 6 alpha cube plus alpha plus 1. So the division will be alpha cube. So 3 plus 3 is 6, alpha 6 plus alpha 4 plus 1. 3 plus 3 6, 3 plus 1 4, 3. So minus we are not writing because Gauss field 2 is there. So one this will be cancelled. You get here alpha raised to 4 plus 1. Again the division will be of alpha. So alpha raised to 4 plus alpha square plus alpha. Alpha something I have done wrong here. Alpha cube, alpha raised to 6, alpha. So what is the alpha cube is alpha raised to 6, alpha raised to 4, and here alpha cube. Here I am wrong. So here alpha cube. Okay, so alpha raised to 4, alpha raised to 4 plus alpha square plus alpha. So that is equal to alpha cube plus alpha square plus alpha. So again division will be of 1. So that is equal to alpha cube plus alpha plus 1. So this will be cancelled out. This will be cancelled out. Remainder will be alpha square plus 1. Why remainder will be alpha square 1? Because 2 is less than 3. Here you are going to stop. So you got the remainder as alpha square 1. So the same answer you got here. So this method is easy easy than or taking less time than this method. But here we are obtaining the elements with the mod operation. That means every element is divided by the primitive polynomial and we are obtaining the mod. So this is easy method than this method. But to have better understanding, I have explained this method also. So if you are liking the concepts you are getting through this channel or through these videos, you can subscribe to the channel.